Hey there, grade 6 teachers. Let's have a look at some ways that you can make connections from computer science into your Earth Systems unit. You probably already know that computer science in grade 6 contains a lot of learning about abstraction. We also see students being expected to use block-based coding language to create some type of computational artifacts and understanding how computers and technology are changing the world and how they may change the world in the future. We know that from kindergarten through grade 6, the organizing idea for computer science refers to computational thinking, design thinking, and creativity, all as being key pieces to computer sciences and computer engineering. Looking at your Earth science systems topics specifically, let's look at some ways that you can connect to not only all of that abstraction that's in your computer sciences, but some of the other computer science concepts as well. Starting right off at looking at climate change and talking about how some parts of climate change are because of natural things and some climate change is because of human activities, and starting to have conversations around what natural processes cause climate change, what are the human activities that cause climate change. We are starting to decompose climate change down into its different parts. We're sorting out the things that are, sort of natural and probably not preventable, and then those human things that are preventable. Then we have that area in the middle where, the natural and the human are coming together to create even more impactful climate change. So through doing discussion, some sorting and grouping of these different things that can cause climate change into two different categories. In this case, we are working through computational thinking. We're decomposing, we're recognizing patterns. This is natural, this is human. We're abstracting it down into that very simple, natural, and human out of we've taken, this many things and now grouped into just these two groups that we can use now for further discussions and learnings and understandings. Looking at something like a climate change cause and effect assignment that you may have students work on to work on some of these skills and procedures that we see in your Earth systems, and then drawing in how computational thinking is sort of connected into this when we're talking about the different aspects of climate change and what climate changes have an effect on living things, because there may be climate changes that don't have as large of an impact on living things specifically, or maybe they impact plants but not animals. So, breaking those down into their parts, looking at all of the different elements is working through that decomposition. When we're asking students to find patterns in something, so we could be looking for patterns in how the types of human made climate change is more impactful than natural climate change. And so there's a pattern in that we see that this is more impactful. We're connecting that together, and again abstracting it down into something very simple in that, human processes equals more climate change. Further into that, can we generalize whether human or natural effects are more harmful? That's actually bringing it to that abstraction level, like I say, simplifying. And then we could move into some algorithm design by asking students to write a set of instructions for how to reduce climate change. And that will have them critically thinking again. We're going back to all those pieces, decomposing it down. What are all the pieces? How can we look at, grouping? Can we group these up so that we can generalize when we're making a set of instructions? Because we want instructions to be simple and concise and to the point. So what can we eliminate? How can we come out with a good, concise set of instructions for how to meet this outcome? We're going to be learning about climate change, thinking critically about climate change, and also transferring in some of that computer science content into that as well. Asking students to compare is asking them to use computational thinking strategies for sure as well. Identifying and discussing technologies that are used to track and predict extreme weather events is an excellent opportunity for you to bring in the computer science skills around computers, coding, and technology having impacts, and how design and coding has a role in society, because we can look at how the technologies that are used to predict extreme weather events have evolved and changed over the years, and how has that changed our lifestyle and quality of life and safety. We're able to be warned about severe weather far in advance. Scientists use advanced computer technology to monitor weather, analyze data, and predict extreme events. And this is a piece where just studying and learning about weather systems is also going to be helping or giving students, this computer science skills and procedures at the same time. And students are being asked in grade 6 to identify examples of abstractions. The weather is a great place to make a direct connection to that, and how the weatherman that we see on TV shows us something that makes a lot of sense to us. There's pictures. If it's going to be a nice day, there's a sun there. That's a very visible thing that I understand immediately. However, what all of those technology systems are gathering and collecting is far more complicated than that. So weathermen abstract the weather data for us into something simple that just tells us what we need to know. We don't need to know all of the numbers and things that are associated. We just need to know, is it going to rain tomorrow? And they do that for us. And that's a really good example of abstraction, that you can make that connection for your students so that they can see how abstraction is used throughout daily life. Relate extreme weather events to specific locations in Canada and on Earth. This is an opportunity for you to have students create an artifact. It could be a computational artifact, would be excellent. So computational artifacts come up as a specific skill in grade 5. That's making something using technology. It can be slideshows, video presentation. It could even be a song or a website. And of course, a computer-based program or something written with some block codes, something that a student makes in Scratch, definitely qualifies as a computational artifact. Plus, they're going to be meeting those outcomes related to block-based coding. Some of those, you can ask them to have some of the structures that are involved in coding that they're expected to learn in grade 6 too. So they could do something like create an interactive map in Scratch based on this sort of design that we see here. We can be working through that computational thinking, looking at the properties of extreme weather, comparing them to each other and looking for patterns. Maybe certain types of extreme weather don't occur in certain locations, or they do always occur. Forest fires are where there are forests, for example. Breaking that down, pattern abstraction. So creating this map would be an abstraction of a lot of other information. And then that algorithm design of writing a rule. Can you write some rules about extreme weather events? Or can you write a set of instructions for what to do during an extreme weather event? And we're having them work through that computational thinking, algorithm writing. They're working with sets of instructions, which is like all of what up to grade 4 is the computer science, is all about writing and understanding and creating sets of instructions. So anytime you ask students to just reiterate something, write up a set of instructions, create a set of rules. We're working with that algorithmic thinking and building skills that will help them develop the computer science skills for that block-based coding as well. And then again, having them actually create this interactive in the block-based coding program is going to be meeting those computer science outcomes and letting the students show you something in a fun way. We have a really big empathize button here because we are looking at other people's perspectives. So when we're looking at elders and knowledge keepers and scientists, anytime we're trying to think like someone else, put ourselves in someone else's shoes, we're hitting on that empathize piece. If we have students create a project, show in some way what they know. So here they're being asked to actually propose ideas. Let's bring in the design process, have students work through this. It's a great place to start with, that empathy, putting ourselves into their position. We're going to be proposing something that they are going to do. What do you think? How are they going to feel? What would they accept from us? Let's start with that empathy. Then we can move through the rest of the design process as we work towards, these ideas or a plan that we're creating regarding people and environments and local climate change. And then in addition to that, we can talk about the possible impacts of computers and coding and technology. Maybe as we're coming up with a plan, we're incorporating how computers could help solve this climate change issue. And we can apply some abstraction here as we're asking them to, get these ideas, come up with your plan, get it down, and now let's put this into something actionable. Let's make step-by-step instructions for this proposal, this plan to help support awareness of local climate change. We've checked off these Earth systems outcomes and then also again brought in a whole bunch of that computer science stuff as well. So the last bit, these last few skills and procedures you probably already know appear in your Earth systems and your energy curriculums. When we are looking at specifically talking about energy use and responsible energy use, and this connects back into the climate change that's in all of the Earth systems and also connects into, our energy use our energy uses and all of the complications and problems surrounding that. So as we have students work through these concepts, again, we can be having them create computational artifacts to show what they know about these. We can have them using the technology to complete their investigations. They're providing a slideshow or they're providing a video presentation. Again, get them to show you something through the Scratch platform, and they're going to be bringing in that block-based coding and even more computer science ideas. As we are breaking things down and simplifying, categorizing, and finding these key traits, we're moving students towards that abstraction. How can we simplify this? How can we look at what only matters? Is it just, the cost that matters? Is it also the societal impacts? Are those as big of an impact as the environmental impacts? And just, breaking things down, making those connections, and finding those abstractions. Examine management of energy resource in various contexts and discussing ways energy resources are used. A lot of this is connecting into the same things because we have that expectation that they're building some block-based coding things. We can always use that to help meet other objectives. It's a great way for students to show what they know. You're not going to have them doing everything they're showing you in Scratch, but they can certainly be doing lots of projects and practicing those computer science and coding skills that are really going to help them out in the future. They're part of your curriculum, but learning to code is going to give your kids a leg up no matter what they decide in the future. And the Scratch block-based programming is going to give them exactly what they need to be able to be successful if they want to do some type of computer programming in the future, whether that be their specific job or it's connected into another career, because there is computer knowledge needed in almost every career field now. With these graphics here, just to stimulate some ideas for you and ways that you can have students address these topics in a variety of display forms, whether we're just, doing those discussions or we have students creating formal presentations. There's lots of opportunities to just draw it back and talk about how, we're focusing on attributes. oh, we're decomposing this, and just connecting in that language and recognizing that when you're brainstorming as a class, that that is a piece of the design process. And also recognizing that you probably have a lot of gaps that students are going to have, especially for the first few years as this new curriculum rolls on, and that we may be looking back at showing them those basic things on algorithm design and, how do you make a peanut butter sandwich, and give me those steps in order. Anytime you can just draw in some of that computer science, whether it's your specific skills and procedures, or you can just make references to computational thinking, design thinking, have students thinking critically about what they're doing, and you're going to be transferring that computer science knowledge in. When we have students work out sorts, you've probably heard me say this before, sorting, categorizing, and grouping, that's working through computational thinking. We have to figure out what attributes matter for this sort. We have to eliminate the attributes out of our view that we don't need to be looking at so that we can hone in, and then eventually, again, having us work towards what is the rule, what is the algorithm for completing this sort. How would you tell someone who doesn't know what this is how to sort things? How would you sort things even though you don't know what they are based on what you can determine about their properties? Students are being asked in grade 6 to design a device that uses energy. And so we could be using batteries, we might be using wind power. You might leave it up to the students what type of energy they're going to use to fuel their device. But you're definitely going to be asking them to use the design process. And this is going to be drawing in that computer science overarching idea, having them practice and actually work through this to complete a project that meets another need is great way for them to further develop their computer science skills. And you can give them some opportunities to apply abstraction by, as they're doing their design and asking, them to abstract it, bring it down to the basics. What do you for sure need to have included to meet this objective? Let's make a simple model to meet this objective. Let's learn about what abstraction is by using it connected to something else. So those are some ways you can connect computer sciences into your Earth Systems unit. I hope you enjoyed.